Assalamualaikum warahmatullahi taala wabarakatuh and very good morning to everyone. So this is the continuous video for chapter 4 Dynamics BMM 1553. Okay, so previously we already discussed about several subtopics under force and acceleration chapter. We already discussed mass, moment of inertia, planar kinetics equation of motion, and equations of motion translation. So for this video, I will continue on explaining about the equation of motion, rotation about a fixed axis. Please take note that for this subtopic, several questions will come out during your final examination. So I will give you several assignments for you guys to complete that falls under this topic. Equations of motion, rotation about a fixed axis. To start, okay, let's consider the rigid body shown here constrained to rotate in the vertical plane about a fixed axis and passing through the pink at O, the pin at O. The angular velocity and angular acceleration are caused by external forces and coupled moment of system that acting on the body. Okay, so the angular velocity and angular acceleration are caused by these forces and also the moment. Alright, due to mass center of mass at G moves around a circular path, the acceleration of this point is best represented of its tangential and normal components. Okay, so in order for you guys to determine force in these motions, rotation about fixed axis, you need to obtain the tangential and also normal components of the acceleration. Alright, the magnitude for tangential component of acceleration is AGT equal to alpha RG and must act in a direction that consistent with the body's angular acceleration alpha. The magnitude for normal component of acceleration is AGN equal to omega squared RG. The component is always directed from point G to O, regardless of the rotational sense of omega. Alright, two components of MAGT and MAGN shown in the kinetic diagram are associated with tangential and normal components of acceleration of the body's mass center. So if you can see here, this is M times A, but tangential component, and M times A for normal components. So MA equal to force. That's why you will get these equations. Okay, the equation of moments can be written as follows. Force normal components equal to M AGN equal to M omega squared RG. Meanwhile, the force for tangential component Ft equal to M AGT equal to M alpha RG. Okay, so the total moment of this system from the body's mass center G equal to Ig alpha. Okay, Ig you already learned before in previous subtopic. Okay, is the mass moment of inertia. Alright. So now, moment about point O. Okay, unknown is FO. FO. So, moment equation at point O is as follows. Okay, moment O equal to RGM AT plus IG alpha. Okay, then you can simplify the equation of motion. Fn equal to MAGN M omega squared RG. Ft equal to MAGT equal to M alpha RG. And then MO equal to IO alpha. Note that MAGN is not included here since the line of action of this vector passes through O. Okay, so now I already include one exercise for under this subtopic and I will attach the solution to you guys, and please do these questions by following the reference of my solution. Okay, and for assignment, okay, for assignment I will give an assignment at the Google Classroom. You should submit your answer as usual in Google Classroom. However, for this time, for this subtopic, I would like you guys to choose two questions. Two questions from Hibler that falls under the subtopic. Okay, two questions. Alright, so you can choose which question you want, but it must falls under this question. If it is not under these subtopics, I will check and I will ask you do it again, and I will direct message you and ask you to redo the assignment. Okay, since this subtopic will come out during your final examination, so please take note. Please take note and take this assignment seriously. And another thing, if I found similar assignment, okay, similar questions from everyone's answer, I will choose randomly anyone and ask you to redo again the questions. So make sure you don't share your question and which one that you choose, and don't share your answer with your friends. Okay, so please do at least two questions that falls under this topic. Okay, rotation about fixed axis. The most important point of this subtopic is this one. Okay, force normal component and force tangential component. All right. So now, lastly, it's the fifth subtopic, equation of motion, general plane motion. Okay, the rigid body shown in figure is subjected to general plane motion caused by externally applied force and Cope moment system. The three equations of motions for the rigid body are Fx, Magx, Fy, Magy, and Mg equal to Ig alpha. You already learned this before. Okay, in some problems, it may convenient to sum moments about point P instead of point G. Thus, in general case, the three equations of moments are, okay, you actually, in this subtopic, it is a summarize of previous subtopic that we already discussed before. So, it's the same. Okay, alright. So, for this type of question, general plane motion, we also can use IC in order to determine the total moment of the system. Okay, we can use moment equation about the IC. If we sum the moments about the instantaneous center of zero velocity, then the moment equation is as follows. MIC equal to IC alpha. Okay, so for the assignment, two questions. Actually, we have finished chapter 4. So for assignment, two questions from equation of motion, rotation about fixed axis, and one question for equation of motion, general plane motion, IC. IC. Okay, so for fourth subtopic, you need to submit two questions. For the fifth subtopic, one question about IC. Okay, on general plane motion. Um, if you submit your question and answer, please write the whole question, okay, and the number of questions from Hibler that you choose. So please write all the question and also your full answer, because I know that in Hibler there is no detail. No detail on solution process. So you need to do your own calculation process and submit it to me. Okay, guys. So actually, we have finished chapter 4 and we have chapter 5 to cover. So please submit the assignment this for this until this coming Saturday. Okay, so I will put the deadline on the Google Classroom. Okay, that's all from me. See you on the chapter 5. Assalamualaikum warahmatullahi taala wabarakatuh.